Horse riding is a popular leisure and sports activity, and the horses' gaits are often subject for evaluation. At Icelandic horse competitions, the horses are evaluated by the quality of their 5 gaits. The judges score the gaits on a scale of 0 to 10 using guidelines created by the International Federation of Icelandic Horse Associations. Gait training is the absolute key for meeting these guidelines. Gait classification is a subclass of behavior classification. Behavior classification concerns the analysis of, for example, wildlife, cattle and horses, and is focused on classifying the general behavior, where gait classification specifically focuses on analyzing the gait patterns. Gait classification exists in both animal and human studies. In human studies, the main focus is using gait pattern as a biometric to identify a single person, while animal studies often focus on wildlife behavior. But because the subjects are not so available, the solutions are often tested on cattle or horses. Current state-of-the-art solutions use IMUs to record accelerometer, gyroscope and magnetometer data to capture the gait characteristics. While image-based solutions also exist, they are impractical and unavailable for the general user. Studies have shown that when classifying IMU data, it is beneficial to structure the data as a time series. This allows a recurrent neural network to learn how the data changes and how it relates to the foot pattern of a specific gait. The data for the model was collected using an Android app, recording sensor data at a rate of 100 Hz. The app progresses through the gaits of walk, tilt, trot, and canter at a predefined rate of 60 seconds per gait, giving the rider 10 seconds to make the transition into the next gait. The rider is alerted with an auditory signal, walk, when they have to change the gait. A session lasts a total of 4 minutes 40 seconds, resulting in approximately 24,000 data points per session. The data is structured in windows to be fed into the RNN model. The window should be large enough to contain at least one cycle of all gaits. Since walk is the slowest, a gait cycle of walk is measured to be 2 seconds, giving a window size of 200 data points. A recurrent neural network was implemented and trained on the recorded data. The baseline model had one LSTM layer with 100 neurons and one hidden layer with 10 neurons. The model was compared to a standard DNN, showing superior performance over it, with an accuracy of 90.09% compared to 61.25% in the DNN. Different model configurations were tested, and it was found that showing no improvements in performance with more than one recurrent layer and one hidden layer. The cross-validation showed high internal validity with an average accuracy of 87.06% with a standard deviation of 3.58 over 10 folds, while external validity suffered from lack of data, yielding an accuracy of only 29.70% with a standard deviation of 12.12 in leave one out cross-validation. It is concluded that a smartphone can be used to capture gait characteristics of the Icelandic horse, and that a recurrent neural network was able to find correlations in the dataset. In the future, the model should be trained on a larger dataset to confirm that it generalizes well. Furthermore, it should be researched how the model can be used in further gait analysis to provide more detailed feedback to the rider.